Dragonflies are some of the most visually striking and biologically efficient aerial hunters on Earth, belonging to the order Odonata. These insects have existed far longer than most modern animal groups. With their iridescent wings, rapid flight, and almost alien-like eyes, dragonflies are often seen near lakes, ponds, and wetlands where they rule the skies as apex insect predators. Their story stretches back hundreds of millions of years, making them one of the oldest surviving insect lineages still alive today. Dragonflies have a prehistoric lineage that dates back over 300 million years, long before dinosaurs walked the earth. Their ancient relatives, part of a group called Meganistoptera or griffinflies, had wingspans that could exceed 2 feet. These enormous predatory insects dominated the Carboniferous period when oxygen levels in the atmosphere were significantly higher than today. Modern dragonflies are smaller, but they retain many of the same evolutionary traits that made their ancestors successful aerial hunters. First known observations in human history. While dragonflies were not discovered in a modern scientific sense due to their widespread global presence, they were first formally described in early natural history writings. Ancient Greek philosophers such as Aristotle observed and recorded insects with careful attention to their behaviors, including creatures resembling dragonflies. However, it was not until later centuries that dragonflies were systematically classified in scientific taxonomy. The first major scientific classification of dragonflies came from Carl Linnaeus in the 18th century. Linnaeus, often considered the father of modern taxonomy, placed dragonflies within his structured system of naming organisms. This allowed dragonflies to be studied consistently across scientific communities. From that point onward, dragonflies became a standard subject in entomology, the study of insects. One of the most remarkable aspects of dragonflies is their flight system. They possess 2 pairs of independently controlled wings, allowing them to hover, accelerate instantly, and even fly backward. Their wings operate with a complex muscle system that enables precise control over each wing stroke. This makes them some of the most agile flyers in the entire animal kingdom. Modern engineers and aviation researchers have studied dragonflies extensively for insights into aerodynamics. Their ability to maneuver in tight spaces, hover with stability, and change direction instantly has influenced designs in drone technology and micro-air vehicles. By analyzing dragonfly wing motion, scientists have improved flight efficiency in small aircraft and robotic systems. Their natural engineering serves as a blueprint for advanced aerodynamic design. Dragonflies have some of the most advanced vision systems in the insect world. Their large compound eyes contain tens of thousands of individual lenses, giving them nearly 360-degree vision. This allows them to detect movement with extreme precision, making escape for prey almost impossible. Their visual processing speed is also incredibly fast, contributing directly to their success as hunters. Dragonflies are among the most successful predators on Earth when measured by hunting efficiency. Some studies estimate their success rate at around 90 to 95%, meaning most of their strikes result in a capture. This level of efficiency is rare in the animal kingdom. Their ability to predict prey movement and intercept in mid gives them a major evolutionary advantage. Dragonflies are strictly carnivorous and feed primarily on smaller insects such as mosquitoes, flies, and gnats. They often hunt mid-flight, capturing prey with spiny legs that form a basket-like structure. Once caught, prey is consumed quickly while the dragonfly continues flying. This aerial feeding strategy allows them to remain constantly mobile and vigilant. The life cycle of dragonflies includes 3 stages: egg, nymph, and adult. The nymph stage is aquatic and can last several months to several years depending on species. During this stage, they are also predators, feeding on aquatic organisms. When fully developed, they emerge from water, shed their exoskeleton, and transform into winged adults. In their nymph stage, dragonflies are just as predatory as their adult form. They use extendable mouthparts called labium to snatch prey underwater. This stage is crucial for growth and survival, as it allows them to build energy reserves for their transformation. The nymphs are also indicators of water quality since they require clean aquatic environments to thrive. Dragonfly mating is a unique aerial process often involving complex flight patterns. Males typically defend territories near water and engage in mid- or courtship displays. After mating, females lay eggs either directly in water or on aquatic vegetation. Some species show remarkable parental site selection to maximize offspring survival. Male dragonflies are highly territorial and will aggressively defend their hunting and breeding areas. They use aerial displays and direct chases to drive away rivals. This territorial nature ensures access to food-rich environments and optimal mating opportunities. Their dominance in these areas reinforces their role as apex insect predators. Dragonflies are found on every continent except Antarctica, thriving in a wide range of environments. They are especially abundant near freshwater ecosystems such as rivers, lakes, and wetlands. Their adaptability has allowed them to survive major extinction events and environmental changes over millions of years. Beyond their biological importance, dragonflies serve as key indicators of ecosystem health. Because their larvae depend on clean water, their presence often signals a balanced environment. Scientists also study them to understand predator-prey dynamics, flight mechanics, and environmental change. Their ecological role extends far beyond their size. From their prehistoric ancestors to their modern role as aerial hunters and scientific inspirations, dragonflies represent one of nature's most efficient designs. Their evolutionary success, aerodynamic mastery, and ecological importance make them a subject of continuous fascination. Long before humans studied flight or engineering, dragonflies had already perfected the art of aerial precision. Visit me at Legion Exotics on Morph Market or legionexotics.myshopify.com, and remember to like, comment, subscribe, and hit the notification bell for more exotic content.